Hello, thank you so much for having me. Welcome to KubeNomad, how to run Kubernetes on Nomad. I'm super thrilled to have you join me here today. This is my second year in a row doing Hashi Talks, so I'm super stoked. Now, before we get started, a little bit about me. As you heard in the intro, my name is Adriana Villela, and I am a HashiCorp ambassador, 2 years running, hopefully third one in a row, fingers crossed. CNCF ambassador, blogger, podcaster. By day, I am a developer advocate in the observability space, spending a chunk of my time working in OpenTelemetry. And by night, I climb walls at my local climbing gym, and I also love capybaras. Clearly, I am a weirdo, and only a weirdo could dare come up with what I'm about to talk to you about today. So here we go. So last year, I posted on the HashiCorp Ambassador Slack asking if anybody had ever tried to run Kubernetes on Nomad. And needless to say, I was met with a lot of, so why exactly do you want to do this? But of course, that didn't seem to me to be weird at all, because after all, Kelsey Hightower dared to run Nomad on Kubernetes, which he talked about in his famous Hashinetes talk at HashiConf in 2017. Now, this is a clip of Kelsey talking about Hashinetes on my podcast, Geeking Out. So now you have one reason to check out my podcast. Here you go.
The Hashinetes talk, because that was the year I was like, okay, all of these tools have been out for a while. Vault is out, Consul is out, Nomad is out, Kubernetes is out. Now what? How do you think about all these things? What do you even do with them? And I remember that year I wanted to have fun. My previous years, it's more about what are these things? And then maybe years after that, it's like it's in production. But I was like, you know what? I want to have a irresponsible talk. I remember starting to talk off. Today, we're going to be irresponsible. Do not do this in production. Do not go to work and say, Kelsey said anything.
So I figured Kelsey did, he did Hashinetes. Why not do it the other way around, right? So last year I thought, oh, hell, I am totally going to do this. I'm going to try to run Kubernetes on Nomad. Now, the thing is, one of the things that I love doing is figuring out how to run things on Nomad that normally run on Kubernetes. Now, it mostly involves converting Kubernetes YAML manifests into Nomad HCL job specs. And I've done it before with things like trace test, temporal, and the OpenTelemetry demo app, all documented in a repo that I have on GitHub called Nomad Conversions, which I will include as a reference at the end of this talk. Now, once the decision was made to go ahead with KubeNomad, it was time to put things into action. So here's my plan. My go-to setup for running Nomad on my local machine is HashiQube. Now, HashiQube is basically this lovely HashiLab environment that lets you run non-enterprise versions of Nomad, Consul, and Vault. And the integrations between these tools are already configured. So you end up with something quite similar to what you would have if you were to run these in a data center, everything single node, mind you. Now, HashiQube also lets you run other tools, but Nomad, Vault, Consul were my main go-to tools when I use HashiQube. Now, all of this goodness runs in a Vagrant machine. Now, as an aside, I do want to give a massive shout out to my friend and HashiQube creator, Rian Nolan, for this awesome tool. Rian was also recently on my podcast, so now you have 2 reasons to listen to it. Okay, so now if you run Vagrant, you'll know that the most common way to run it is with the VirtualBox provisioner. But unfortunately, I plan to run this little setup on my M1 Mac. Now, if you run Vagrant on a Silicon Mac, you know that it does not play nice with VirtualBox. And instead, you need to run it using the Docker provisioner, which, thanks to Rian, HashiQube can now run with both VirtualBox and Docker provisioners. So with keeping all this in mind, my final setup would look like this. So we've got HashiQube running on Docker Vagrant, and then Nomad running on HashiQube, Kubernetes running on Nomad via Docker. And of course, I needed a way to test all of this goodness. So I would also need to deploy something on Kubernetes to make sure that Kubernetes was running properly. And to do this, I planned to deploy Jaeger, which is a CNCF tool for visualizing traces in Kubernetes. So in case you lost count, that's Docker, in Docker, in Docker, or 3 layers of Docker, or just pretty much madness. So yes, I did this. So now that I had my architecture all figured out, I needed to get cracking on trying to figure out how to run Kubernetes on Nomad. Now, when taking a wacky project like this, the best thing to do is to try to keep things as simple as possible. So I thought of running some sort of super lightweight Kubernetes distribution. So I looked into Kind or Kubernetes in Docker, I looked into Minikube, and I looked into K0s. And K3s. And I ended up landing on, finally, K0s because it is super lightweight Kubernetes distribution. It is relatively easy to run, and it is already containerized for your convenience. Now, one of the ways to run K0s is via Docker Desktop. So I figured it took a lot of the guesswork out of it for me because it's nicely documented in the K0 site. And having that documentation in place meant that all I needed to do was create a Nomad job spec as a wrapper to that already containerized K0s. So piece of cake, obviously, haha. Now, before getting started, I also needed a little help from my Hashi friend. I met Luiz Aoqui on Twitter back in 2021 when I started my Nomad journey, and turns out he is a fellow Brazilian living in Toronto, Canada. What are the odds? Now, Luiz is a developer on the Nomad team and is an active member of the Hashi community, and you've probably seen him post on Hashi Discuss a bunch. And I've had the pleasure of having him on both my podcasts on Call Me Maybe and Geeking Out. So now you have 3 reasons to check out Geeking Out. So when I decided to embark on this journey of running Kubernetes on Nomad, I pinged him to let him know what I was up to. And it was kind of a, hey, look at this ridiculous idea that I had. I'm totally going to go through with it. And he's like, cool, down for a collab. All right, it's on. But first things first, before running K0s on Nomad, it's important to make sure that you can run K0s locally on your machine using Docker. Disclaimer, I did not do that. I skipped straight to trying to run it on Nomad, which was the most terrible idea, but this is what you should be doing in real life. So anyway, running K0s locally on Docker. Here we go. So this is the Docker command that I use to get things up and running. And let's take a closer look of what is going on. So first, we need to run Docker in privilege mode as per the K0s docs. And as I mentioned before, I was running this little experiment on my M1 Mac, and according to the K0s docs, etcd is not fully supported on ARM architectures, which means 2 things. So first, I needed to add this runtime environment variable called etcd unsupported arc. And secondly, I also needed to explicitly invoke the K0s controller command against the K0s container, all because of the Silicon Mac business. And because of that, I also needed to explicitly add this enable worker flag, which adds a worker node to the controller. And without this option, K0s just spins up a controller, but no worker nodes. Now, in Kubernetes, jobs are scheduled on the worker. So if you have no worker, it basically means you can't actually deploy anything, which is kind of useless to us. Now, it also meant that I had to add this no taints flag. Now, by default in K0s, controller nodes running with the enable worker flag are automatically tainted. So you need to pass the no taints flag to disable this behavior. Now, taints prevent pods with certain attributes from being scheduled on the node. So we have to remove this taint, otherwise we can't run anything. And finally, per the K0s docs, I needed to pass these 2 flags related to C groups to the Docker run command. Now, a control group or C group is a Linux kernel feature that limits an application to a specific set of resources. And this includes things like CPU, memory, disk I/O, and so on. So it limits the usage of these resources. Control groups allow the Docker engine to share available hardware to containers and optionally enforce limits and constraints. So, for example, you can limit the memory available to a specific container. Now, setting cgroups ns to host tells Docker to run the container in the host machine's cgroup namespace. And according to the K0's docs, if you're using Docker Desktop as the runtime starting from version 4.3.0, it's using cgroups version 2 in the VM that runs that engine. So these flags basically ensure that kubelet and containerd work properly with cgroups version 2. Great. So once I was happy that K0's was up and running properly locally via Docker, which of course I did that beforehand, then it was time to translate this lovely configuration to a Nomad job spec. Now, as I mentioned before, my goal was to create a Nomad job spec as a wrapper to that already containerized K0's. Piece of cake, right? Of course. So this is what that job spec looked like. Now let's dig a little bit deeper. The kubectl command connects to the cluster at localhost 6443, which is why we expose port 6443 in the Docker run command. Because ultimately we want to be able to access Kubernetes. We do that through kubectl, so we need to expose that port. Hence, we must also do the same for our job specs network stanza. And we're exposing this as a static port, meaning that K0's will be available via port 6443 on Nomad. And this Nomad we label it K0's, which maps to port 6443, which gets referenced later in our task definition. Next, we have our volume definitions. So the K0's Docker run command mounts a volume at /var/lib/K0's in the container. In Nomad, the job spec uses a host volume to accomplish this. Now, host volume is used for stateful workloads, which means that if your job dies or fails, you don't lose data because the volume is in Nomad's file system and not in the container's ephemeral file system. And it's the equivalent of a persistent volume in Kubernetes. Now, the job spec references a host volume called K0's, and you might be wondering, okay, where is that defined? This volume is defined in the Nomad client config HCL file, which here's a sample of it right here, and it's pointing to a location in the Nomad file system, which is /opt/K0's. Now, we are ready to define the Docker task in the job spec. Let us compare first the Docker run command to the Docker task configuration in the Nomad job spec. So first we have the Docker image definition, and we pass the K0's command over here and the various arguments, including the controller and the enable worker and no taints flags. Now, you may recall from earlier that we do need to run K0's in privileged mode, which means that we need to set that privileged flag to true in the job spec. But in addition to that, we also have to go back to our good old friend, the Nomad config HCL, the Nomad client config, and configure that Docker plugin to allow privileged. Otherwise, not going to work. But we're not done quite yet because there's one more configuration left. Now, you may recall from earlier that the K0's documentation states that we need to set cgroups ns to host. Great, no problem, right? Just add cgroups ns to our task definition, right? Easy peasy lemon squeezy. But there is just one teeny tiny problem. The Nomad Docker task driver does not support a cgroups ns flag. Now, at this point, I was ready to give up, but fortunately, Luiz came to the rescue for me. And this is definitely one of those times where it pays to have friends at HashiCorp, wink, wink. So Luiz was able to create a special build of Nomad for me that supported the cgroups ns flag. Now, in case you're wondering, you will not be able to find this feature as part of the standard Nomad build because, as it turns out, there needs to be a little bit more due diligence that has to occur before cgroups ns can be added as a core feature. So this one-off build exists, made just for me by Luiz to satisfy both our curiosities. And there was also a PR put out for this feature, which is now closed, but perhaps someday it'll be reopened and this feature can be integrated into Nomad. Luiz and I now figured that once we had the cgroups ns thing sorted out, it would be smooth sailing from here on in, but alas, we were not quite there yet. And now this part is probably the most like not in my wheelhouse component of this experiment. And Luiz and I kept basically seeing these containerd error messages in the K0's logs of the Nomad job spec. Now, Luiz was fortunately able to figure out that there was something super funky going on with containerd configuration in K0s that didn't play nice in the K0s running on Nomad, due to the fact that we had a Docker and Docker situation going on here. Definitely very unnatural. So fortunately, he was able to use guidance from the K0's docs to grab a copy of the containerd configuration file being used on K0s, so that he could then make one single change to a single config element and basically feed that file back into K0s in the Nomad job spec. And so here's a snippet of what that looks like. The containerd config file is ridiculously long, so I did not include the whole thing on there. But so this is just a snippet, and this is the teeny tiny little config that Luiz figured out that needed to be changed in order for this thing to work. So hats off to him for this and the C groups NS thing, because yeah, we would have been up a creek without those two changes. And then the last thing we needed to do, obviously, was to make sure that that task config points to the updated containerd config file. And with that, we are finally ready to deploy K0s on Nomad. Hurrah! Now, obviously, before we wrap things up, I did want to show you a quick demo of Jaeger running on Kubernetes, running on Nomad, so you know that I wasn't scamming on you. But also, I am not a glutton for punishment, so I did do a video recording of this setup so as to avoid inevitable tech failures, fingers crossed, and awkward pauses that come up while waiting for services to start up. So without further ado, here we go. Okay, so here we have the HashiCube startup sequence. Now, normally this takes a few minutes, but I sped things up to move it along. And once it's up and running, we can pull up our browser to access Nomad UI at localhost 4646. Now, as part of my bootstrapping sequence in HashiCube, I also started up Traefik, which, as you can see, started up successfully. So now it's time to turn our attention to deploy the K0's job spec. So we head over to the Nomad UI to see how things are going, and we can see that it just finished deploying. Now, of course, just because the Nomad job deployed successfully does not mean that it's actually running properly. So we'll need to verify things by going into our Kubernetes cluster. Now, at this point, you will also need to have kubectl installed locally on your machine in order to get this part up and running. So we start by getting our Nomad jobs allocation ID so that we can remote into our K0's container running in Nomad to grab its kube config file contents and pop the output into our local kube config file. Now, remember that we originally exposed port 6443 in our Nomad job spec, and that's the port that kubectl will be using to access Kubernetes from your local machine. So we can, in a sec, go and check on our cluster. Now, first, let's get the status of our single Kubernetes node by running kubectl get nodes. Now, we created a single node cluster, so this command should output a single node. Now, this node is acting as both the controller and the worker. And we can see from running the command that we have a single node and its state is ready. Good news for us. It means that the cluster appears to have been created properly. That's one good thing already. Woohoo. Now, just to be on the safe side, we should also check to make sure that our core Kubernetes services are up and running. And we do this by running kubectl get pods. And then we make sure that all of the required services are running. So we'll see that in a sec. And we see that here. Yay. And finally, we are ready to deploy Jaeger to Kubernetes. So we'll do that now by applying the YAML manifest for Jaeger using kubectl apply. And then we check the deployment status of our pod, and ta-da, everything looks good. And finally, we will do a port forward so we can actually access the Jaeger UI. And it means that Jaeger should be available to us at localhost 16686. So we will go there in a sec. Fingers crossed. We see the Jaeger UI, so as expected, which means that we have a Jaeger container running on a K0's container, running on Nomad, on the HashiCube container. Ta-da! Totally wild. So that was fun, but what was the point of all this? What did I learn? So at the end of the day, I wasn't doing this to solve some great tech problem. Rather, I just wanted to see if I could do something cool with two technologies that I love and learn something very interesting along the way. And I think I accomplished that. Running Kubernetes on Nomad was a fun little experiment, and I'm super glad that I did it. Mind you, it took way longer to get this up and running than I'd anticipated, as these things do. There are always hurdles along the way. Especially considering that, K0's was already containerized. I thought this thing was in the bag, no problem. But, there was definitely a lot of time spent pouring through logs, scratching heads, Googling. And fortunately, I was lucky to have had help, a partner in collaboration crime. So I'm super grateful for that. Now, even though I'm not entirely sure if there's a practical application for what I was doing here, I still learned a number of things. And to me, that's the ultimate reward. And here are some of the things that I learned from this little escapade, both technical and non-technical. So first, there's the power of networking and communication. I would have never met Luiz had I not written my articles on my Nomad learnings and posted them on social media in the first place. My Nomad journey started, 2+ years ago. And I had to put myself out there for that. And if I hadn't reached out to Luiz when I was doing this experiment saying that, hey, I'm doing this, he would have never offered to help. It taught me a little bit more about Docker. For example, I never understood or appreciated things like C groups and what they were for and why we needed them. So now I do. I don't need it for my day-to-day job, but it's still kind of cool to understand why these things are used, right? And it taught me a little bit more about Kubernetes. My past experience of Kubernetes has always been around deploying apps and configuring service mesh tools like Linkerd and Istio and playing around with GitOps tools like Argo CD. And this gave me the opportunity to dig a little bit deeper under the covers than I would have otherwise. Having to look through Kubernetes logs gave me this huge appreciation for all of the moving parts that make up Kubernetes and why they're important. Now, we often take for granted the technology that we rely on. We just think it works. And we also take for granted the people behind the technology. So my call to action for everyone here is to pair with somebody and try to do something absolutely weird with technology, because you'll never know what you can learn from it. So thank you so much for sticking around. Be sure to check out these super useful resources if you'd like to dig deeper into my K0's Nomad adventure. It includes links to HashiCube, to my Nomad conversions repo, the accompanying blog post, and of course, my interview with Kelsey Hightower. And in case you're wondering, all of the images in this deck were generated by AI, because while I can't draw, I'm one heck of a prompt engineer. So thank you to our evil AI overlord, Bing AI, powered by DALL-E 3. You are awesome. Be sure to check out my podcast, Geeking Out with Adriana Villela, to hear more conversations with fellow tech geeks and to geek out on cool tech topics. You can scan the QR code to find it on various podcasting platforms or on YouTube if you like videos. And finally, I would absolutely love to connect with you. Reach out if you have any questions or would like to talk more about any of the topics that I covered today. This QR code will link you to all of my socials. Now, before I sign off, whenever I write a blog post or do a talk, I always like to wrap up with a photo of my rats. Yes, I am a rat person as well as a capybara person. So here are my rats, Phoebe and Mookie. They are good friends. Until next time, peace, love, and code.